All right, so today we are going to learn about triangles. All right. Now, triangles, of course, have three sides, three angles. All the angles within a triangle have a sum of 180 degrees. So, with that being said, if I have angles such as, let's say this is 100 degrees, and this one is 50 degrees, obviously this one has to be 30 degrees because they all have to make 180 degrees. Okay, you probably already know that. The different types of triangles, we have an equilateral triangle, right? All sides and angles are equal. As you can see, they all have 60 degrees. All right, equilateral triangles are always going to be 60, 60, and 60. All the sides are equal. Okay, so this side is 5, this one is also 5, this one is also 5. All right, now um, the next one, isosceles triangles. Okay, so we have two of the same sides, and one of them is not going to be equal. Okay, so you have two equal sides and two equal angles. Notice how the angles are across from the equal sides. Notice how their angles are across from the corresponding sides. Obviously, this angle is smaller here in this picture, so this side would be smaller. That's across from the angle, right? This side would be smaller. All right, that's an isosceles triangle. Next, we have a scalene triangle. No equal sides, no equal angles. Nothing is congruent on this triangle. Notice how the lines are different. You have one line, two lines, three lines. That means that they're all different sizes. Same thing with angle. One angle here, two lines here, three lines here. They're all different sizes. So, for example, this would be something like, let's say, 3, 6, and 10. Okay. And then the angles would be something like, let's say this is 100. This one is, let's say 40. Nope. Let's say 55. And this one would be 25. Okay. They're all different angles. Okay. Now, when we talk about triangles, we have to have a theorem for it. There's a theorem that makes a triangle. I don't know if you guys know this or not, but the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. So you have to check all the sides to make sure that they are actually a triangle. If this were not true, then it would not be a triangle. It would have a gap somewhere, right? The sides would not connect. For example, let's say A is 7, uh, C is 3, and B is 6. So let's check this inequality. A plus B has to be greater than C. So A and B is 7 plus 6. And that's greater than 3, obviously, yes. Next, A is 7, C is 3, and that's greater than 6, right? 10 is greater than 6. The last one, B plus C, 6 plus 3 is greater than 7. That's true. So this gives me 3, 6, and 7 can be a triangle. Now, for example, what if I had these numbers? Let's say 4, 8, and 15. Let's check. Let's say this is A, this is B, and this is C. Let's check. So this would be, and I'm using this same formula here. 4 plus 8 is greater than 15. Is that true? Absolutely not, right? So this would not make a triangle. So your points have to use this inequality or this formula to make a triangle. If it doesn't work for any one of these lines, then it is not a triangle. We're going to do more problems like this tomorrow.